Good morning, all. The next example, or you can say the last example in the Jacobian point is if u equal to x upon y minus z, v equal to y upon z minus x, and w equal to z upon x minus y, then show that Jacobian of UVW with respect to xyz equal to 0. So we have to find Jacobian of UVW with respect to xyz. So the formula is in the form of determinant. So first row is derivatives of u with respect to x, with respect to y, and with respect to z. Second row is v derivatives vx, vy, vz, and the last row is w derivatives, that is wx, wy, wz. So here from the given equations we have u, v, w are the functions of x, y, z. So while we take the derivative with respect to x, that time y, z are constant, and with respect to y, xz are constant, and with respect to z, xy are constant. So here ux, so with respect to x, 1 upon y minus z is constant, and x derivative with respect to x is 1. Then with respect to y, u derivative with respect to y is, with respect to y, xz is constant. So x as it is, and derivative of 1 upon y minus z, because the denominator contains y term. So 1 upon y minus z derivative with respect to y. So we have to apply 1 by x formula. 12th standard formula is 1 by x derivative is minus 1 upon x square, but 1 upon single variable is not there. Instead of x, we have given y minus z. So we have to apply bracket formula or 1 by b derivative. So minus 1 upon b square into derivative of b. So here minus 1 upon b square, that is y minus z bracket square, into b square, derivative of b. So b value is 1 upon term is your b value. So 1 upon is y minus z. So y minus z derivative with respect to y. So y derivative is 1, minus z constant, derivative 0. So we have the u derivative with respect to y. Then with respect to z, again x is constant, and 1 upon derivative is minus 1 upon bracket square and into derivative of b. So y minus z derivative with respect to z. So with respect to z, y is constant, derivative 0. With respect to z, minus z derivative is minus 1. So it will be plus x upon y minus z bracket square. Similarly, you can find the derivatives of v with respect to x, y, z, and w derivatives with respect to x, y, z. So here vx with respect to x, again y is constant, and upon derivative is by using 1 upon b derivative formula, 1 upon z minus x bracket square minus 1 upon z minus x bracket square into derivative with respect to x of derivative of b. So derivative of b is z minus derivative with respect to x is minus 1. With respect to y, so with respect to y, 1 upon z minus x is constant, right as it is, and y derivative with respect to y is 1. With respect to z, y is constant, and 1 upon derivative is 1 upon z minus x bracket square into z minus x derivative with respect to z is 1. Because x is constant, derivative is 0. Now the last is w derivatives. With respect to x first, then y, and then take z. With respect to x, z is constant, and 1 upon derivative is minus 1 upon b square into derivative of b is, with respect to x, derivative is 1, because x derivative is 1, minus y derivative is 0. With respect to y, again z is constant, and 1 upon derivative is minus 1 upon bracket square into x minus y with respect to, so minus 1 upon b square, into derivative of b. So b derivative with respect to y. So with respect to y, x derivative is constant, derivative 0, minus y derivative is minus 1. Then with respect to z, 1 upon x minus y is constant, right as it is, which is multiplicative constant, and z derivative with respect to z is 1. So this is your partial derivatives. Now don't simplify this or don't evaluate this determinant directly. First check the determinant properties. So here we have 1 upon y minus z bracket square. You can take 1 upon bracket square as common. Same type of example we have seen in previous lecture, that in this example, as 1 by x square is not seeing common in 3 terms, but we have taken 1 by x square common because we want this minimum or smallest values inside the determinant notation. Hence, we take this squaring term common. So, same type of step we have to take here. So, take 1 upon y minus z bracket square common from the first row, then 1 upon z minus x bracket square common from the second row, and from the third row take 1 upon x minus y bracket square common, and the determinant elements will be, we have taken 1 upon y minus z bracket square, so here we have to take y minus z extra in numerator. 1 upon y minus z bracket square common, remaining element is minus x. 1 upon y minus z bracket square common, remaining element is x. Then next is 1 upon z minus x bracket square common, remaining element is y. 1 upon z minus x bracket square common, so extra we have to take z minus x, and 1 upon z minus x square common, right, y. So here again 1 upon x minus y bracket square is common. We have taken 1 upon x minus square bracket square common, so the remaining elements in the third row is are z, minus z, then z, and here x minus y. So this is your step. Now you can simplify directly this element with the multiplication of these terms, or you can write as, or you can again use the determinant property. So here we have taken bracket square term common and then apply the row transformation, as because in previous example we applied the column transformations, that is c1 minus c2, c2 minus c3, so that we get the determinant which is easy to evaluate. So the smaller terms we got inside the determinant notation while applying the column transformation. So again you can use the determinant property, that is here y minus z is term, and here in second row there is a y, and here in third row there is a minus z. So if we take the transformation as r1 minus r2 plus r3, so we have to change r1, so rest of the rows as it is. Here there is a minus sign. And the first row will become r1 minus r1 is subtracted from r2 plus r3. So r2 plus r3 is y minus z, and this y minus z is subtracted from y minus z, that is first term. So we will get 0. So then minus x r1 minus r2 plus r3. So z minus x plus z, that is 2z, and this minus this term, addition of this term is subtracted from this first term. So r1 minus r2 plus r3. So this is the addition, z minus x plus z, that is 2z, and minus x minus z plus x. So minus x plus x get cancelled, and this is minus z, that is minus 2z. So here we have minus 2z. So if we have the rough calculation, r1 minus r2 plus r3, so we have r1 element is minus x, then minus z minus x plus z. So we have minus x minus 2z minus x. So minus x minus 2z plus x. So we get minus 2z. Then third element in the first row is r1 minus r2. So x plus y. So write the take the addition of these two, r2 plus r3. So minus y plus, so minus y minus 2y, and this is minus x. So this x subtracted from this addition. So r1 minus r2 plus r3. r1 minus r2 plus r3 gives r1 element is x minus r2 plus r3 is minus y plus x minus y minus 2y plus x. So x plus 2y minus 6. So it is 2y. So we have here 2y. So the benefit of applying the determinant properties are two, or you can say three. That is, the first is take the common terms outside the determinant notation, and then second is apply the column transformations, that is C1 minus C2 or C2 minus C3 or C1 minus C3. We have to first check the elements. On the basis of the elements given in the examples, we have to apply the column transformations, that specific column transformations. And the third is row transformation. So here in this example we have applied the row transformation because the elements are like y minus z. So why we have applied this row transformation here? Because we get the zero number. So if we get the zero values or number of zero elements inside the determinant notation, then it is easy to evaluate the determinant. So here by applying this R1 minus R2 plus R3, we get 0 here. So it is easy to evaluate this determinant rather than this determinant. So don't evaluate this determinant directly here. First apply this row transformation and then evaluate. It is easy one, or you can get the answer easily in the minimum steps. So here now the common terms write as it is, and then evaluate the elements. So 0 into any number is 0. So first term get cancelled. Minus 2z get plus because the middle term has the minus rule, minus sign, which is in the rule of the evaluation of determinant. So middle term has minus sign. So that minus sign from the rule, and this minus sign get plus. So 2z into this multiplication, z minus x, x minus y minus zy plus 2y into yz minus this multiplication. So this multiplication is minus z square, and the rule minus sign will be given the terms as minus z square will be plus z square, and minus plus zx will be minus zx. Simplify this denominator terms as it is, and this is 2z into xz minus zy minus x square plus xy minus zy, and plus 2y into yz plus z square minus xz. So if we simplify this, 2xz square here we have the minus sign, it is left. So here this minus y, so 0 minus 2z, then x r1 minus r2 plus r3 is x minus plus y, x plus y, and then again minus sign. So x minus x get cancelled, so plus y and again plus y, that is 2y. So now simplify this determinant separately. We have 0 2z minus 2z 2y yz minus x minus y minus z x minus y. So this is minus plus 2z into y into this term. This corresponding column and row deleted. So minus rule and this minus sign. So rule minus sign, the minus sign from the rule, and this minus sign get plus. So this is 2z. So 2z into y into x minus y minus plus again rule minus sign, that is minus zy. Then plus 2y into yz minus this into this, that is minus z square plus xz. So 2z xy minus y square minus yz plus 2y yz plus z square minus xz. Simplifying, we have 2xyz minus 2zy square minus 2yz square plus 2y square z plus 2yz square minus 2xy. So this get cancelled, then plus y square z minus y square z cancelled, and 2yz square get cancelled. So we get the value 0. So this value has 0 value. So 0 into any number is 0. So we get the prove that answer. So here 2z into y into x minus y. So here there is a y. So y into x minus y, minus minus plus, again minus zy, and plus 2y into yz plus z square minus xz. So simplifying, we have 2z into xy minus y square. So after simplification, so this is the simplification. So minus y square plus yz. So instead of this, you can write this. So this is the corrected step. So this is your last example. In the Jacobian. So now let us see the next point, that is Taylor theorem and Mclaren series point. So here there are the examples which ask in the exam is like expand the given function. So if you check, the given example is like expand the given function, and the function is given in the xy variables. In both the variables the function is given, and we have to expand that function. Then we have to use the Taylor series or Mclaren series. So Taylor's theorem is this, and then we can see the Mclaren's formula. So the Taylor's theorem is, if f of xy is the function of xy, then at the point xy equal to ab, some particular point is given. So at that point the Taylor's theorem is given by, or the expansion of the given function is given by, f of xy equal to f of ab plus x minus a into fx ab plus y minus b into fy ab plus 1 by 2 factorial x minus a square double derivatives fxx plus 2x minus a y minus b fxy plus y minus b bracket square fyy plus 1 upon 3 factorial x minus a cube. Hence there are triple derivatives fxxx plus 3 into x minus a square y minus b fxxy plus 3 into x minus a y minus b bracket square fxyy plus y minus b bracket cube fyy, etc. and so on. So as this formula is Taylor series formula, hence in the exam you can write the first 2 or 3 terms. Just check the marks for that example. So here how to remember this formula. So first term is f of ab. F of ab means the whatever the given function f of xy, in that we have to put the value of x equal to a and value of y equal to b in the given function. So we get the f of ab value. Plus in first bracket there is a single derivatives fx and fy, and with fx the bracket is x minus a, and fx is your partial derivative of f with respect to x, fy is partial derivative of f with respect to y. Then fx at that point ab plus here there is a term fy, hence the bracket is taken as y minus b. Then the second term is your second derivative terms, containing second derivative terms in the form of like a plus b bracket square formula. So this you can remember as a plus b bracket square formula type expansion. So 1 upon 2 factorial a square, so x minus a square fxx plus twice ab, so twice x minus a y minus b. So here we have taken x minus bracket, hence here fx, and y minus b, hence we have to take y. So x minus a, this bracket is related to fx, and y minus b, this bracket is related to fy. So you can remember in this form. So twice AB fxy plus b square, that is y minus b bracket square fyy, plus the third term is like expansion of a plus b bracket cube, a cube plus 3a square b plus 3ab square plus b cube. So a square means, a cube means x minus a bracket cube, triplet derivatives fxxx plus fxxx plus 3a square b. So x minus a square, y minus b. Here we have taken x minus a square 2 times, so hence we have to take fxx, and y minus b only once, so we have to take only y. Then 3ab square, so x minus a, y minus b bracket square. So here we have taken x minus a single, so take x, then y minus b 2 times, then take yy, fxyy, plus b cube means y minus b bracket cube fyy at the point ab. So this is your Taylor series formula. Then Maclaurin's series formula for the two variables is, uh, uh, there is no need to remember the Maclaurin's theorem formula separately, because if we put a equal to 0 and b equal to 0, that is at the origin, this Taylor's theorem formula is reduced to Maclaurin's formula. So remember only Taylor's series formula, and if we put AB equal to 0, 0 point, that is A value is 0 and B value is 0, that is at the origin means 0, 0 point. So if we put A equal to 0 and B equal to 0 in this Taylor's theorem formula, we get the Maclaurin series formula. So let us see the examples. So first is expand f of xy equal to e raised to xy at the point 1, 1. So here the point is given, so this is your AB point. So we have given a equal to 1, by comparison we get a equal to 1, b equal to 1. Now first find f of AB. So we have given f of xy equal to e raised to xy. So f of AB is, that is f of 1, 1. So put x equal to 1, f of 1, 1. F of AB means f of 1, 1. So put a equal to 1 here, or f of AB means put x equal to a and y equal to b, and AB values are 1, 1. So put x equal to 1 and y equal to 1. So here e raised to 1, 1 is e. Then fxxy means, here fxab means take the derivative of given f of xy with respect to x, and in that put the point ab. So here fxxy means fx derivative, so f derivative with respect to x. So with respect to x, here f is your function of xy, so f is a function of xy. So while we take the derivative with respect to x, y is constant, and with respect to y, x is constant. So e raised to xy derivative with respect to x. So e raised to b formula we have to apply. So e raised to b derivative is e raised to b into derivative of b. So e raised to xy derivative is e raised to xy, and xy derivative with respect to x is y. Put here x equal to 1 and y equal to 1. So e raised to 1 into 1 into 1, that is we get e. So fxab equal to e. Then fy derivative is, take e raised to xy derivative with respect to y. So e raised to b derivative is e raised to b, that is e raised to xy derivative is e raised to xy into derivative of b. So xy derivative, here b value is xy. So xy derivative with respect to y. So with respect to y, xy derivative is x, because x is constant, and y derivative is 1. That is xy derivative with respect to y is x. Again put x equal to a and y equal to b, that is ab values are 1, 1. So put x equal to 1, and here xy we have to put x equal to a and y equal to b, and ab values are 1, 1. That is we have to put x equal to 1 and y equal to 1. So e raised to 1, 1 into 1, that is we get e. Then fxx, that is from fx again take the further derivative with respect to x. So from fxx we get from the fx value. Again take the derivative with respect to x. So with respect to x, y is constant, write as it is, and e raised to xy derivative with respect to x is e raised to xy, derivative is e raised to xy into xy derivative with respect to x is y. Again put x equal to 1, y equal to 1, we get e. fyy means this term we get from this derivative. So fy further derivative with respect to y, with respect to y we get fyy. So e raised to xy into x, with respect to y, x is constant, right as it is, and e raised to xy derivative with respect to y is e raised to xy derivative is e raised to xy, and xy derivative with respect to y is x. Again put x equal to 1, y equal to 1, we get e. F of xy. So f of xy we get from the fy. Because f of xy notation means here we have to obtain first f of y. That is f derivative with respect to y. So this is your term. And then fy derivative, next derivative with respect to x gives fxy. So fy derivative with respect to x. So with respect to x, there are two terms in product form in which e raised to xy contains x variable, hence this is your variable term, and the second term x contains the x variable. That is both are variable terms, and we have to use their product rule. So here e raised to xy as it is, x derivative with respect to x is 1, plus x as it is, e raised to xy derivative with respect to x is e raised to b derivative. So e raised to b derivative is e raised to b into derivative of b with respect to x is y. Again put x equal to 1 and y equal to 1, we get e plus e, that is 2e. fxxx means triple derivatives, that is take fxx next derivative, we get fxxx. So with respect to x, y square is constant, right, as it is, and e raised to xy derivative is e raised to xy into xy derivative with respect to x is y. Again put x equal to 1, y equal to 1, we get e. Fyy derivative means fyy next derivative is with respect to y gives triple derivative fyy. So with respect to y, x square is constant, right, as it is, multiplicative constant, and e raised to xy derivative is e raised to xy into xy derivative with respect to y is x. Again put x equal to 1, y equal to 1, we get e. Next is fxxy. That is we have to, so we can find this derivative term from fxy. So fxy is this. So from this term we get this derivative. From fxy we get fxxy. So fxy is this. So we have to take this derivative, the derivative of this term with respect to x. So with respect to x, y is constant. So here, so this term is easy, so you can check first. So e raised to xy derivative with respect to x. So e raised to b formula. So e raised to b derivative is e raised to b into derivative of b. E raised to xy derivative is e raised to xy into derivative of xy with respect to x is y. Then what is the derivative of first term? So in first term y is constant. So you can write y as it is and derivative of x into e raised to xy. So y write as it is y, and which is multiplicative constant, and x into e raised to xy with respect to x we have to use product rule. So x as it is, e raised to xy derivative is e raised to xy into xy derivative with respect to x is y, plus e raised to xy as it is into x derivative is 1. So this is your product rule. So here we have y into e raised to xy, y into e raised to xy plus xy square e raised to xy, or xyy e raised to xy, xyy e raised to xy. So again put x equal to 1, y equal to 1, we get this, both the terms, first and last term is, you can merge. So this is 2 times y e raised to xy plus xy square e raised to xy, and put x equal to 1, y equal to 1, we get 2e plus e, that is 3. And fxyy we get this derivative, third derivative term by using fyy next derivative with respect to x gives fxyy. So fyy is this. So this the derivative of this term with respect to x gives fxyy. So with respect to x, this is your x square e raised to xy. So we have to use product rule because x square into e raised to xy contains both the terms contains variable term. So here fyy is x square is e raised to xy. So we have to take the derivative of fyy with respect to x, we get fxyy. So we have to use product rule. So x square as it is, e raised to xy derivative is e raised to xy into xy derivative with respect to x is y, plus second term as it is into x square derivative with respect to x is 2x. Again put here x equal to 1, y equal to 1, we get e plus 2e, that is 3. So this is your fxyy. So put these terms, all the terms in the Taylor series formula. So f of AB is e plus x minus a value is 1. So x minus 1, y minus b value is again 1. So x minus 1, y minus 1. The bracketed terms reduced to x minus a reduced to x minus 1, y minus b reduced to y minus 1. So x minus 1 into first value is e. Fy value is e. So x minus 1 e plus y minus 1 e. This is your first term. Plus 1 upon 2 factorial. X minus 1 square, double derivative is e. All the double derivatives fxx e, fyy e, and fxy is 2e. So x minus 1 square e plus 2 into x minus 1 y minus 1 2e plus y minus 1 bracket square e. This is your second term. Plus 1 upon 3 factorial. Triple derivative is e. X minus 1 square, x minus 1 cube e plus 3 into x minus 1 square y minus 1 into fxxy is 3. So this is into 3 plus 3 into x minus 1 y minus 1 square into fxyy. 3 plus y minus 1 bracket cube fyy into e. So simplifying, 1 upon 2 factorial means 1 by 2. 1 upon 3 factorial means 6. That is 3 into 2 into 1. That is 6. And simplify, e plus x minus 1e plus y minus 1e. So take e common. So we have x plus y minus 1 that is minus 2. Plus 1 upon 2. Take e common. So in bracket x minus 1 square plus 4x minus 1 y minus 1 plus y minus 1 square plus 1 upon 6 x minus 1 cube. Take e common. So x minus 1 cube 3x minus 1 square y minus 1 into 3 plus 3 into x minus 1 y minus 1 square into 3, that is 9 plus y minus 1 cube. So this is your no need to expand this square and cubic term. So this is your expansion of given function e raised to xy. So how to solve the given example by using Taylor's theorem, or what is the example which is or how to check with which example is your Taylor's theorem or not. So the question is like expand. If that word is given in in question, then we can guess that this example is of Taylor's theorem. So here expand the given function. The function is given f of xy and the point is given. So that point is your AB point and the given function is your f of xy point. So find the derivative values or derivative terms, single derivatives, double derivatives and triple derivatives at that point AB, that is put x equal to that point, given point, and y equal to the second ordinate. This is your x coordinate, x coordinate and y coordinate. So x value and y value, that is your given point which is given in the example. So find the partial derivatives at that point and put all the values in this given theorem or Taylor's formula, and by after quite simplification we get the answer. So the next example is, this is your assignment example. Expand f of xy equal to e raised to x cos y at 1 pi by 4. That is here a value is 1 and b value is pi by 4. So f of xy equal to this. So f of ab means put x equal to a and a is your 1. So put x equal to 1 and y equal to b means y equal to pi by 4. So by if there is a important point that if the trigonometric functions are in given function, then use radian setting on in the calci. Radian means there should be R letter on the screen of your calci, and first set or first fix the calci with radian option and then do the calculation. So this is your assignment example. Next is again, this is your assignment example. Expand the given function. So f of xy is given. So in this example there is nothing to remember, just remember the formula, Taylor's formula and Mclaren's formula. So here the half calculation is about the partial derivatives, and these partial derivatives we have studied many examples, how to use the bracket formula, how to use the 12th standard formula. So such type of examples we have studied or we have learned in previous lectures, that is in the first point partial derivative, in the second chapter in the first point. So if you practice first point, then easily we understand the Taylor's theorem and Mclaren's theorem also, because these type of examples contains 50% partial derivative calculation. So this next example is expand. The function is given f of xy equal to e raised to x sin y in powers of xy as far as the term of the third degree. Means expand means you can guess that this is the example of Taylor's theorem or Maclaurin's theorem. So this is your example of Maclaurin's theorem, because here if in the example the question is like expand the given function f of xy is given with the particular point AB point is given, then that example is of Taylor's formula or Taylor's theorem. We have to solve that example by using Taylor's formula or Taylor series formula. If the point is not given, in this example the point AB is not given, so we have to use Maclaurin series formula. So Maclaurin series formula means that is your Taylor's formula, but we have to put AB point as 0, 0 point. So this is your you can take as an assignment, because just we have to put A value as 0 and B value is 0 in the Taylor's theorem or Taylor series formula. So that is your assignment example. So here in this example again it is given that we have to expand the given function in the powers of xy. So this is your previous example. So once we apply the Taylor's formula, we get the powers of x and powers of y equation. So if we expand this cube, then we get x cube, then we get y square, y cube, etc. term. So while we apply the Taylor's formula or Maclaurin series formula, at last we get the many powers of x and or varies we get the powers of different powers of x and y. So that is the same example which is asked in the other language, that is in powers of xy means we get the various powers of xy at the last, that is in the answer of the given example. As far as the terms of third degree means x cube, y cube terms should be included in the last answer. So here while we solve the example at the last, by putting a equal to 0 and b equal to 0, we get these xy terms with various powers with y cube, x square, y, that is this is a cubic term. X power is 2, y power is 1, that is the total power is 2 plus 1, that is 3. So cubic terms we get also at the last answer. So this is called the term of the third degree. So expand means we have to use Taylor's formula or Maclaurin series formula. So if point is given, then use Taylor's formula. If point is not given, then use Maclaurin's formula. So point is not given means we have to take the point AB as 0, 0 point. So put A equal to 0 and B equal to 0 in Taylor's formula. Next example is find first 6 terms of the expansion of f of xy. So here we have to find the first 6 terms of the expansion. Expansion, expand, these type of words we asked in the exam, which is related to the Taylor's formula or Maclaurin's formula. So expansion means we have to use Taylor's or Maclaurin's formula. Expansion of f of xy. So f of xy is given in the powers of xy. So lastly we get the various powers of xy. So here point is not given, so we have to use AB point as 0, 0 point. So f of xy is e raised to x log 1 plus y. So f of 0, 0 equal to put x equal to 0 and y equal to 0, because we have to take here the point is not given, so we have to use Maclaurin's formula, and in Maclaurin's formula the point is AB point is we have to take as 0, 0. So f of 0, 0 equal to Put e raised to 0, that is 1. Log 1 plus 0, that is log 1 is value 0. So log 1 value is always 0 here. Log 1 means on calc it is ln option. So ln of 1 is 0. So on calc log 1 means ln 1, it is 0. Then fx. So take the f derivative with respect to x. So with respect to x, y is constant. So log 1 plus y is constant, write as it is. E raised to x derivative is e raised to x. Now find fx 0 0. Fx 0 0 means put x equal to 0 and y equal to 0. So e raised to 0 1, log 1 is 0. Again we get 0. Fy. F derivative with respect to y. So with respect to y, e raised to x is constant, multiplicative constant, write as it is, and log 1 plus y with respect to y. So log derivative is 1 upon, so we have to use log b formula. So here we are used log b. So log b derivative is, log x derivative is 1 by x, log b derivative is 1 by b derivative of b. So log 1 plus y derivative is 1 upon 1 plus y into derivative of b. So 1 derivative is 0, y derivative with respect to y is 1. That is, there is no need to write 1. So fy derivative is e raised to x upon 1 plus y. Again put x equal to 0 and y equal to 0. We get 1. E raised to 0 1. Anything raised to 0 is 1. So 1 upon 1 plus 0, that is 1 by 1 is 1. Fxx, next derivative. E raised to, with respect to x, log 1 plus y is constant. E raised to x derivative is e raised to x. And add 0 0, we get 0. Fyy means take the derivative of this with respect to y. So with respect to y, e raised to x is constant, right as it is. And 1 upon derivative by using 1 by b formula. So 1 by b derivative is minus 1 upon bracket square b square. So 1 plus y square into derivative of b. So b is your 1 plus y. 1 plus y derivative with respect to y is 1. 1 derivative is 0 and y derivative with respect to y is 1. We get this. Again put x equal to x equal to 0 and y equal to 0, we get minus 1. So minus 1 upon 1, that is minus 1. Fxy. Fxy means so the next term is fxy. Fxy means fxy derivative means fy next derivative with respect to x is fxy. So with respect to y, again e raised to x is constant. So 1 upon 1 plus y derivative is minus 1 upon 1 plus y bracket square into 1 plus y derivative is 1. And put x equal to 0 and y equal to 0, we get 1. Then fxx, then fyy, fxxy. Fxxy means it comes from fxy next derivative with respect to x. Fxyy means it comes from fyy derivative with respect to x. So fyy derivative next derivative with respect to x gives fxyy. Fxy next derivative with respect to x gives fxxy. So you can find easily the partial derivatives and put the value x equal to 0 and y equal to 0. We get these terms. We get these values. Put these values in Taylor's formula. Taylor's formula with a value is 0, b value is 0 and all the derivative terms. We get these terms and simplifying. After simplification, we get the various powers of x. That is first power, 1 plus 1, second power term, second power term. This is your third power term, 2 plus 1. Total term power is 3. Total term power is 3. 1 plus 2, 3. Y cube, that is third term or third degree term. So here the example contains the question is like expand this function, that is we have to use Taylor's or Mclaren's. Point is not given, so take AB equal to 0 0 point. So put AB equal to 0 0 in Taylor's formula, we get the Mclaren series formula. So we have to use here point is not given, use Mclaren's formula. Mclaren's formula means put AB equal to 0 0 in Taylor's formula. Then as far as the term of the till the in powers of xy, find the first 6 terms. 6 terms means we have to find the first 6 terms. So 1, 2, 3, 4, 5, 6. So the 6 terms we will get when we expand or when we extend this Mclaren series up to the third derivative terms. So this is your third derivative terms. We will get the six terms. First six terms. So first term, second term, third, fourth, five, six. First six terms up to first six terms. We will you can expand the given function f of xy. Next is expand f of xy equal to cos x cos y as far as the term of the third degree. That is the last answer contains the third degree terms. So obviously it contains, so no need to calculate, or there is no need of the separate calculation for the third degree answer. So expand means we have to use Taylor's or Maclaurin's formula, and the point is not given, so we have to use Maclaurin's series formula. That is, put AB equal to 0 0 in Taylor series formula. So this is you can take as a assignment. So in assignment, the function is given in the trigonometric function, so use the radian option while we find, or while we put AB equal to 0 0, that is x equal to 0 and y equal to 0. So this is your Maclaurin's and Taylor series formula. So 50% example contains the partial derivative terms, and 50% example or 50% calculation is partial derivative calculation, and 50% calculation is your substitution and simplification. So the next point we will discuss in the next lecture. Thank you.